Now we will see the step-by-step procedure to draw the Bode plot. As we know that Bode plot has two plots, magnitude and phase plots. First we see steps that are to be followed to draw the magnitude plot. Step number 1. We know that Bode plot is drawn for the open loop transfer function to find the stability of the closed loop system, or to analyze the closed loop system, or to design the closed loop system. So step 1 is look at the open loop transfer function, convert that into time constant form. So we know the time constant form, g of s or gh of s is k, which is a gain, into 1 plus sz1 into 1 plus stz2. So stz1 into stz2 dot 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 upon we have s power p into 1 plus stp1 into 1 plus stp2 dot dot dot. So I have poles, but not in the form of direct poles. We have pole frequencies and as well as the time constants. Similarly, I have zeros in the time constants. So everything in the time constant, therefore this is called time constant form of the transfer function. So the p indicates how many number of poles that are there at the origin. So not only s power p here, sometimes the poles may be, these s terms will appear in the numerator, which means there are origin zeros or infinite zeros in the transfer function. Now, so the first step is we need to convert the given transfer function. If it is not in the time constant form, convert the given transfer function into your time constant form and write the corner frequency. We know what are the corner frequencies. Corner frequency is the frequency at which the magnitude plot changes its direction. It is also called break frequency. Now the corner frequencies are pole frequencies or zeros frequencies. So let us extract from those corner frequencies and write here. Let us say omega c is my corner frequency. Omega c1 I can say 1 divided by tz1, omega ct is 1 divided by tz2 and so on for zeros. And again I can say omega c, let us say 3 is 1 upon tp1 and again omega c4 1 upon tp4 dot dot dot. So these are the corner frequencies of corresponding finite zeros and finite poles. Corner frequencies available only for finite poles and finite zeros, and also for quadratic factors. If the quadratic factor is available in the numerator, then take the omega n. Even the denominator also, the omega n is the corner frequency. Now rearrange these corner frequencies in increasing order, which means omega c1 is the lowest frequency out of all the corner frequencies, and then omega c2 increasing order, then omega c3 and so on. The final corner frequency will be the highest frequency of all these corner frequencies. So we need to arrange them in the increasing order. So once you arrange them in the increasing order, we need to assume two more frequencies here. The first frequency is omega L. Omega L is the lowest frequency, or omega L we should take it as the frequency which is lower than the lowest frequency. Then one more frequency is omega H, is the frequency which we need to assume higher than the highest corner frequency. Therefore, if omega c1 is my lowest corner frequency, omega L should be less than omega c1. Omega L can be anything. Similarly, omega H is the greater than the highest corner frequency. So once we have these corner frequencies omega L and omega H, then we can fill this particular table in step 2. What is this table contains? So this table will have columns. The first is the corner frequency, second is the corresponding term, and third is the slope of that particular term, and next is the last column is change in slope or the next slope I can say. So these are the 4 columns I have. Then once you have corner frequencies, terms, slope of that particular term and the next slope or change in slope, then what are the rows? Then here we should take all the frequencies which are available. So I will start with omega L, then you can take omega L or you can ignore this. The first term, because the first row is of the first term. So we start from the second one, omega C1, the first corner frequency, omega C2, omega C3 and so on. And in a second column, we have already corner frequencies. What are the corresponding terms? Because we are writing these corner frequencies in increasing order. That can be a pole term, that can be a zero term. So therefore, we are writing in increasing order. Right. So what are the terms? We know that the first term we have either it is k into s power n or k by s power n. This is going to be the first term. Then what is the slope of it? We know the slope of each term. For it is k, the slope is 0. For k into s power n, slope is going to plus n 20 dB for decade. In fact, the slope is dB for decade. And k by s power n, that is minus n 20 dB for decade. Next, we assume this slope as S naught. So S naught I am taking as the initial slope. This is the initial slope of my magnitude plot in the lower frequency end. Therefore, what is the change in? So it is the starting. So the change itself is this. Therefore, I will assume it as S naught. That S naught is, you have either it is 0 or minus plus 20 plus n 20 dB for decade or minus n 20 dB for decade. Any one from these three as S naught. This is the first row we need to fill. The first row is of the first term in the transfer function k into s power n or k by s power n. Now we start with the corner frequencies. So I have omega c1. For this omega c1, what will be the term? That can be either finite zero or finite pole, or quadratic term in the numerator, quadratic term in the denominator. Out of these four, any one will come here. And what is the corresponding slope? We have table available. From this table, then we can write what is the corresponding term. Let this is my frequency S. Let us say this frequency, you can take it as some x1. So this frequency is x1. Then what is the change in frequency? The change in frequency is, I can write it as S change in slope. Change in slope I can write as S omega c1. So omega c1 is my frequency, is corner frequency omega c1. I will write it as S omega c1 is equal to S naught plus whatever the slope we got x1. So I am going to place there. That means this and these two are added to get this. Similarly, omega c2, we know what is the corner frequency. Write down corresponding term, either open finite pole or finite zero, or the corresponding quadratic factors. And what is the corresponding slope? And this is x2. So this x2 will be added to the S omega c1, which is available there. So S omega c2 is equal to S omega c1 plus x2. So this and these two are added to get this. So we have this added to this to get this. Again I am taking this added to this to get this. So this is continuously followed till we reach the last corner frequency. So this table is important. Once you have this table, then we can do the simple calculations and we can get one table which is having one column is the frequency, other column is MdV values. Then we can plot very easily. Now what is this S omega c1? S is the slope, omega c1 it is at omega c1. At omega c1, the first corner frequency, what is the slope?